Hello, here's your video for today. It is on section 3.2, Pythagorean relationships. Right, so before we dive into that, we need to take a little bit of time and talk about right triangles. And we've got isosceles triangles and equilateral and all that sort of stuff, scaling. What makes a right angle triangle is that it has a 90-degree angle. Right, and to mark that, little boxes in the corner. Now it's going to be the corner opposite the really long side. By really long, I just mean longer than the other two. Now those other two sides, we give a special word. This purple one and this purple one. We call them the legs, right? And they're the shorter of the three sides. The long side, we call this one right here the hypotenuse. Hypotenuse. Okay? So that's this side here. Interesting fact, it is always opposite 90-degree angle, and it's always the longest side. Important stuff to know as we dive into the Pythagorean relationship. Now, this relationship says that a right angle triangle, or a right triangle, remember that means 90 degrees, with sides A, B, and C, where side C is the hypotenuse, right, remember that the hypotenuse is the longest side, is going to have a formula a squared plus b squared equals c squared. Right? Now what this is saying is that something squared, right? Just like when we talk about like centimeters squared, that's talking about an area. So this is saying that, okay, if this is side A, if we made that into a square, that area plus the area off of B, if that's a nice pretty square, is going to equal the area of C, right? So if I added this purple plus this blue, I should get the area of green. A squared plus C squared equals C squared. One of the most common formulas you'll probably use your whole math career, right? And maybe in your career outside of school too, depending on what you do. Right? So I want to show you how to use it well. So here we go. This one says, right, just kind of getting us comfortable with the idea. We've got a 90-degree triangle. We know that, I know it's kind of hard to see, but this is triangle A here, right, is a length of 5 millimeters. So that means that this side, 5 millimeters. C, right here is 15 millimeters. And B is 12 millimeters. Right, we know it's a right angle triangle. Find the areas of these three sides. So if we were trying to find the area of A, you know the area of a square, right, is side squared. In this case, 5 squared, or 5 times 5, or 25 millimeters, don't forget your units, squared. Right, so that's the area of A. Okay, so pause the video, and why don't you do the area for B and C. Okay, welcome back. Now this says, what's the length of the hypotenuse of one leg of a right angle triangle is 4 and the other leg is 7? So if you're given a question with just words and no picture, you need to draw the picture. Okay, so step number 1, draw a picture. There's my right angle triangle. It doesn't have to be perfect, right? It's just a sketch. Now it says I'm trying to find the hypotenuse, right? So that means I'm trying to find that side. Right, so one side's 4, one side's 7. Doesn't matter which is which, however you draw it, however you label it, we'll all get the same answer. Step number 1, that's my picture. Now remember that the hypotenuse is always the C, right? In this formula that A squared plus B squared equals C squared, hypotenuse is always C. Whoops, squared. That's what I'm trying to find out. Now the A and the B, you can mix them up. Maybe this is A, this is B, or maybe I want this to be B and this is A. Like I said, it doesn't matter. 2 plus 3, plus 3 plus 2, you always get 5. So let's substitute these numbers in. This is 7, right? This is 4, but you're supposed to square these, right? So we're talking about the areas. It's not the side length. 7 plus 4 isn't going to get me the length of C. It's the area of 7 and the area of 4. So 7 squared plus 4 squared is c squared. Okay, so 7 squared, 7 times 7 is 49. All right, 4 squared, 16. That's going to give me c squared. So into your calculator you go, or maybe you got this one in your head. Right, we've got 65 equals c squared. Awesome, great, good to know. But you want to find the length, right? If this is squared here, this means you've got the area. So to find the length, to get rid of this exponent, I'm going to do the opposite operation. And guess what? Right? We talked about opposite to adding is subtracting. Opposite to multiplying is dividing. Opposite to finding an exponent or squaring a number is finding the square root. And that's what you guys did last time. So I want to get rid of that squared, and remember, just like last unit, I want the c all by itself. To get rid of that 2, I'm going to take the square root of both sides. So in your calculator, you're going to look for a button that looks like this. Now you might have to hit the button first, then the number, or maybe the number, then the button. Every calculator is different. But when I put it in my calculator, I get a big long decimal. I'm just going to round it to, whoops, 1 decimal place. So that would be 8.1 centimeters is C. Right? Makes sense. Longest side, right? 4 and a 7. Right? It's not too big, right? It's not that 65. That 65 doesn't really make sense. Right? So that's how you use the Pythagorean relationship. Kind of cool, eh? So let's take a look at the next two, right? So this one, what time are we at? Okay, don't want to take too much of your time. So this one says, what's the area of the unknown square? So I've got a picture. Don't need to draw one. Just need to write my formula, right? First step, picture. Second step, formula. Now, these are already areas. So when I'm plugging this into my formula, remember that C is always the long one, right? That's what I'm trying to find out, big side. I'm going to write in 16. Oh, wait, I guess we should match it, right? A is 4. I'm not going to square that again, right? This says centimeters squared. That's the area. So I don't have to square it. I'm just putting in 4, right? And 16. Add those two together. I get 20. So the area of this guy is 20 meters squared. Okay. Okay. Let's try the next one. Again, you're going to find an area. You're already given areas. Right? So here's my picture. So then comes my formula. This time, you've got the big one. So I'm going to put it over here. 81. Right? It's already been squared. Don't square it again. B is what you're trying to find out, or B squared rather. And here's the 36. So you know what to do. Look at that. We did questions like this last unit. We want to get B by itself. Minus 36, minus 36. Looks familiar, eh? So in my calculator, I'm going to go 81 minus 36. Right? These guys, they cancel. So B squared equals 45. Right? That's what I'm going for. I'm going for the area, so I stop. I don't want to find the square root. Right? The area of A, 45 meters squared. All right. Let's keep going. So, here we go. Side lengths of a triangle. 5, 6, 8. I want to know, is this 90 degrees? Who knows, right? Kind of looks like it. I drew it to look like 90 degrees, but I need to know that I'm absolutely right. Is it a 90-degree angle? Is it a right triangle? So, if this formula works, A squared plus B squared equals C squared, that'll mean it's a right angle triangle. If it doesn't work, it's not. By work, I mean, remember that we're going to keep it balanced. Left side equals right side. We're into all that algebra stuff that we've been doing for so long. So, let's see. Now, the big number is C, the number by itself. 8 squared. Right, and you can see here, now I have side lengths. So if I'm given the length, I've got to square it, right, whoops, to make it into an area. If I'm given an area, no squaring. Length, I got to square it. Now, like I said before, it doesn't matter. This could be A, this could be B. All right, let's make it 6 squared and 5 squared. So when I add these two together, if it equals 64, 8 times 8, that means that I can put a 90 degrees in there. If not, then I can't. Let's see. 6 times 6 is 36. 5 times 5 is 25. Check this out. 64. They're not equal. So the answer is, no. It's not a right triangle. Right? And the explain part, you explained in the math. That's great. And maybe it's a scalene, obtuse, right? All those different types of triangles. We just know it's not a right triangle. Okay. So, hopefully that's feeling okay. These two questions are going to be your homework, right? So, number 1, number 2, right? First step, draw a picture, right? This says you have a triangle that's got a 4 centimeter side and a 12 centimeter side. You want to find the hypotenuse. So that was like the question, where is it? Up here, right? Exactly the same way, right? So you're doing it on your own down here, right? But this time that was 4 and 7. This is 4 and 12. 2 is a little bit tricky. This time you're given the hypotenuse. You're trying to find the leg. Okay, see what you can do, and check your answers online for the following day, and we'll see you in class. Good luck.